Dear students, the topic which we are going to deal today is the timeline of quantum mechanics. So before getting into our topic, there is a common question which is what is meant by quantum mechanics. So quantum mechanics is nothing but a branch of physics which deals between the interaction between the atoms and their respective properties which are got from their interactions. Okay. The very first milestone for quantum mechanics is laid by the famous German scientist Max Planck. So he gave the concept known as quanta. So according to him, each and every particle or each and every object and or each and every atom in this universe is made up of packet of energies known as quanta. Later, the term quanta is termed into quantum mechanics. Here in this picture, I have shown different radiation types in wavelengths and different frequencies in hertz and their approximate scales of wavelength. Now, if you see for the tall building, we are having the wavelength range of about 10 power 4 hertz, whereas the frequency is about 10 power 4 hertz and the wavelength is about 10 power 3 meters. When we come to our scale, so the frequency is about 10 power 8 hertz, whereas the wavelength falls between somewhat 10 power minus 2 and 10 power 3. So likewise, we are observable in meters and centimeters, etc. The same thing goes for needlepoint protozoans, that is microorganisms. Here I have shown. So for them, the wavelength region is about 0.5 into 10 power minus 6 meter, whereas the frequency falls between 10 power 15. Here there is a region which starts from the blue color and ends in red color. So this region we call as visible region. So this is the region which is responsible for all the visualizations which we are observing in our daily life. So whatever the thing you are seeing in your daily life, all these things falls in this visible region. So after that visible region, the molecules are observable in the wavelength region of 10 power minus 8 meters and hertz of 10 power 16. So after that, the atoms are observable in X-ray region, and after that the atomic nuclei comes. So where we have 10 power 20 hertz and wavelength of about 10 power minus 12 meters. So in this picture you can observe a common observation that whenever the frequency increases, the wavelength falls. So which can be given as E equal to h nu, or otherwise nu equal to 1 by lambda. That is, the frequency, the term frequency is inversely proportional to the wavelength. So whenever the wavelength increases, the frequency decreases. Whenever the frequency increases, the wavelength decreases. The next milestone in quantum mechanics is laid by the famous scientist Dr. Einstein. So through his experiment named as Photoelectric Effect, so which I am going to show here. So in this picture, I have shown a metal surface where the radiation is incident, and whenever the radiation is incident on that metal surface, the electrons in that metal surface are getting ejected. So there should be a phenomena, or there should be an effect which is making this electron to get ejected. So the effect which is happening here is whenever the light radiation falls on this metal surface, the radiation is get absorbed by the electrons in this metal surface, and with higher energy they can't stay stable in their surface and they are getting directly emitted, so they are coming out of the metal surface. So this effect is called as photoelectric effect. It is photons are playing major role here. That is, photo is known as light, and the light incidence making electrons to eject, which is responsible for flow of electrons, which again creates current here. So that's why this is known as photoelectric effect. So this experiment also played an important role in the timeline of quantum mechanics. In order to rectify the contradictions between classical mechanics and quantum mechanics, the another term which was coined by Dr. Niels Bohr, that is the orbitals of electrons in an atom. So according to him, the electrons inside the atom are revolving around the nucleus like the planets in our solar system, which used to revolve around the sun. So based upon that concept, he derived a concept that the orbitals of the electrons are going to be circular. So the likewise I have shown in this picture. So the orbitals around the nucleus which are laid by the electrons are seem to be circular. But the atomic models which are devised after Niels Bohr give a different result, that the first orbit of electron around the nucleus only looks circular, whereas the rest of the orbitals around the nucleus are not circular, meanwhile they are elliptical. So this observation also termed or acted as an important milestone in the quantum mechanics. Okay. In this picture, I have shown an additional detail of the jumping of electrons from the orbitals to their neighboring orbitals. Whenever an electron jumps from the nearest most orbital to the nucleus to the farthest most orbital of the nucleus, it absorbs radiation. That is, it have to gain some radiation to jump to the higher level. Whereas whenever a radiation falls from farthest most orbital to the nearest most orbital of the nucleus, it emits radiation. So these two important phenomena are also observed by Niels Bohr and the scientists after Niels Bohr who devised atomic models. Nowadays, quantum mechanics is visualized or witnessed in almost everywhere. For example, the bulb in your home or the electronic device now which you are using to visualize this class is almost working based upon the quantum mechanical effects. The electronic items like capacitors, transistors, whatever the thing you are seeing in our circuit, all of them are working due to the effect of or based on the principle of quantum mechanics. I am going to give a simple example. There is an effect known as quantum tunneling. You people might hear about that. So the quantum tunneling effect is the chief effect which is governing almost all electronical equipments all over the world. So these are the few glimpses in the timelines of quantum mechanics, and I have given the major application of quantum mechanics also here. So in our next class we will get into our core topic of quantum mechanics. Thank you, students.